Hey guys, before we continue to 2.6, I want to do a really quick recap from our last couple of sections. We talked a lot about limits. There's a lot of different styles and ways to approach them. So let's take a look at this. Looking at 2.2, 2.3, and 2.5, let's try to summarize the way we try to approach finding a limit. And so see, I've got a few bullet points, just kind of what circumstances present themselves and how you go about it. So I'll just start at the top there. If f of x is continuous at x equals a, all we need to do is plug in. Note that that type of continuity is a two-sided continuity where we're just taking the regular limit as x approaches a. So it's got to be like that two-sided continuous. If it's continuous, then we know we can just plug in, and that's true for any of those 7 types of functions in that theorem: polynomial functions, rational functions, root functions, trig, inverse trig, exponential, and logarithmic. Obviously, we deal mostly with polynomials and with rational functions. If it's in the domain, all you got to do is plug in. What if there's a hole? And we would know that if, that's kind of funny, plugging in gives 0 over 0. So we attempt to plug in, we get 0 over 0. Then we'd say, okay, what we're going to try to do is simplify this, and then we'll try and plug it in again. So simplifying might look like factoring and canceling. Simplifying might look like multiplying the top and the bottom, maybe if there's a square root involved, by a conjugate, and then cleaning it up and canceling and then plugging in again. What if there's a hole and simplifying is not possible? So we had an example back early on. It was like the sine of x over x, and x was approaching 0. So if we tried to plug in, we'd have 0 over 0, but we can't simplify sine of x over x. The only way to go about it from there is a table. All of these, we're assuming that we don't have access to the graph. Okay, if we have access to a graph, that's a whole nother story. But if we're not, and if we're kind of supposed to approach this as if we don't have access to a graph, then a table is the only way forward there. If there's a vertical asymptote, same thing. That was for infinite limits. We would know there's a vertical asymptote if we got some non-zero number over 0 when we tried to plug in. So we recognize there's a vertical asymptote, we got to use a table. So it's the only way to do it. And there we're looking for, are the values going to infinity or negative infinity? We also want to note, when we use a table, that depends on if we're looking at a one-sided or a two-sided limit, right? A one-sided limit, we'd only need like the one table, either the left or the right. A two-sided limit, we need to do both, and they need to agree. What if there's a jump? So if there's a jump, that could happen with a piecewise function. The left side and the right side might not go to the same place. We would confirm that by looking at the limit as x approaches a from the left versus the limit as x approaches a from the right. We look at both of those separately. Are they going to the same place? If they are not, they're not equal, then the two-sided limit does not exist. It's D and E. If they do equal each other, then the limit would exist and it would be that value. All right. And then note, kind of at the bottom, just wanted to say this one more time to be really clear. Note that using a table to find the limit value is a last resort. Students tend to, in my experience, want to use tables for everything. Sometimes, maybe the way I'm presenting it now, lets you know when it's appropriate and when it's not. Tables are only a last resort. We never know for sure when we do a table. So if it came to a quiz or an exam, I would always be really clear, hey, for this one, I want you to use a table. Or if it's not appropriate, then I'll say something else like use algebraic methods would like indicate, to simplify or something like that. Only use a table for those circumstances that are stated above. All right, you guys, that's all I wanted to say. We'll move on to 2.6 next video.